Okay, let's talk about some types of potentiometers. And at the end of this video, we'll also look at a few applications of potentiometers. So, one thing that you could do with potentiometers is not just have linear displacement measurement, but you can have a rotary displacement measurement. And here's one example of a rotary uh, displacement measurement. So think of this: you have a wire. Instead of having just a straight wire, you curl it around in a circle, as shown in this figure, and then you have this wiper moving up and down. So it's basically rotating, right? And if you measure the resistance from this point till the wiper, you should be able to get, so the resistance is going to be proportional to the angular displacement here. Okay, so these kinds of potentiometers, which can measure one turn or around 360 degrees of angle, are called single turn potentiometers, and they are easily available uh, in the market, and they look something like these. Okay, you can have multiple turn angular displacement measurement devices. So you don't just have one turn of 360 degrees, but you can actually measure greater angles than that. And the way you do that is basically you take this linear displacement sensor that we already talked about, right? Which basically has a spool or a card, and there's wire wound about it, and this wiper moves up and down and makes a potentiometer. And what you do is you connect this wiper to a screw, so that as you rotate the screw, this wire moves up and down. And that's the idea here. Can you see? This is the shaft, and as this shaft rotates, uh, the the connector here, the metal wiper which is here, moves up and down. So this moves up and down, and it touches the resistances, which are the wire which is wound here. If you look at this, there are some wires wound here, and you can see that at the bottom as well. And this is the wiper which moves up and down with rotation. Okay, so you can have single turn potentiometers, and you can have multiple turn potentiometers. Let's talk about resolution once more. In the previous video, I talked about the resolution of these linear potentiometers, and I said, well, you can have these resistances which are just made of one wire, but and the resolution is going to be theoretically infinite, but practically it's going to be limited by noise. But the resistances that you can actually make with these kinds of wires is not going to be more than 10 ohms, just because it's a straight wire. Um, Similarly, the case for a single turn potentiometer. For a multiple turn potentiometer, either a rotary one or a linear one, you can have resolutions that are the resolutions of displacements that are very, very small. So if you take a very thin wire, let's say you take a wire whose diameter is something like 20 micrometers or 50 micrometers, then you can get resolutions of which are very, very fine resolutions. And you can get total resistances of potentiometers which are up to a few mega ohms, depending on how you construct these potentiometers. Let's look at a few applications of um, potentiometers. Okay, so let's take a look at the simplest, I think, application of a potentiometer. And this is a goniometer. A goniometer is a device that measures the angles, which basically measures angles. Okay, and it's used quite often in biomedical instrumentation to measure angles of joints. So in this case, you are measuring the angle of the elbow joint, and what you're basically doing is you have these two rulers that are pivoted at a point, and at this point you can have a potentiometer put. Okay, in this case, in the figure, you have just uh, angle measurement thing here, but you could have a potentiometer here. And what happens is, as the elbow joint moves, the two rulers move and they rotate up and your potentiometer then can measure the displacement if it is put at the pivot, right? So that is one application. Here's another application. This device is called a spirometer. A spirometer is basically used uh, to measure the breathing of a person. So here's a mouthpiece, and as the person breathes in or out, the pressure inside this area changes, and because of that, this bell jar moves up and down. Okay, and as it moves up and down, what happens? This is connected with a pulley to this weight here. And one way to record the movement of this bell jar would be to have a rotating drum made of paper, and just let it make the squiggly lines which correspond to the displacement of this jar. But another way you can measure it is by having a potentiometer here, which is connected to this weight. And as this weight moves up and down, what you can do is you will have a change in resistance, and that change in resistance can be converted into a change in voltage by applying a voltage across the potentiometer, and we can read the voltage out from the wiper, and that makes a sensor, right? So you are measuring the displacement of this bell jar. Spirometers are especially used in exercise labs. They are used to measure the function of your lungs, uh, and are quite popular devices in medicine. Here's another interesting application. Here, what you're doing is you want to look at how the muscle contracts, uh, or how much the muscle contracts, and you want to see the bulge of the muscles as the person is doing different kinds of activities. So you put the potentiometer here, and if the muscle contracts, uh, basically what will happen is, as the muscle contracts, it bulges, and as it bulges, these two teeth are pulled apart, and as they are pulled apart, that displacement is recorded by the potentiometer. And of course, you want the once the calipers are pulled apart, you want them to come back, and that resistance is given by the spring that is connected here. This is called a caliper myograph. It's basically recording how the muscle is working and how much contractions are there in muscles. So these are a few examples of areas where you can use potentiometers.